Hello everyone, welcome to our chemistry. Today we will discuss 10 questions from alcohol, phenol, ether chapter. In this video I will discuss about the 10 questions only and how to study the organic chemistry and how to cover the whole chapter, which part we have to study basically. That video is already there and link is given in the description box. So follow the link for the revision part, and here I am going to discuss about the 10 questions only. And in that question I have tried to take 10 questions from 10 different parts, except that also few questions there will remain from other parts also. So let's discuss the 10 questions. Let's get started. Our very first question is the order of acid strength. So the first question, order of acid strength, here assertion is given: are CO2H greater than phenol, H2O then ethanol, and reason is given as acid strength increases, pK value increases. So we have to consider which of the following will be the correct one. First, if you go for the acid strength, carboxylic acid will have the highest strength, that one is correct. Then phenol, then water, then alcohol. So the acid strength is correct one. Assertion is correct. About the reason, more the value of K, higher the K value, higher will be the acidity. As with the increase of K value, acidity increases, so pK value decreases. So if acidity increases, pK value decreases. As the acid strength increases, pK value increases. So this one is not true. Here assertion is true, but reason is false. Option B is the correct option. Let's go for the second question. In our question number 2, it is given when phenol is treated with CHCl3 and sodium hydroxide. So here is our phenol. When phenol is treated with CHCl3 and sodium hydroxide, the reagents are used are the reagent of Reimer-Tiemann reaction, and in the Reimer-Tiemann reaction with this reagent, CHO, a aldehyde group, will be added at ortho or para position. So as ortho position aldehyde group can be added here, which of the following will be the possible answer? Salicylic acid, benzoic acid, salicylaldehyde and benzoaldehyde. We know ortho position aldehyde group if contains in a phenol compound, then that will be the salicylaldehyde. So the answer will be salicylaldehyde. Next, in question number 3, we have considered the following alcohols: 1 phenyl, 1 propanol, 3 phenyl, 1 propanol, 1 phenyl, 2 propanol. The correct sequence of the reactivity of this alcohol in their reaction with HBr. Let's draw the compounds. For 1 phenyl, 1 propanol, this one is the propane chain, and at one position OH is there, and at one position pH is there. So this one is 1 phenyl, 1 propanol, CH3, CH2, CH, OH, pH. In that 1 phenyl, 1 propanol, then we have 3 phenyl, 1 propanol. In the 3 phenyl, 1 propanol, at 3 position phenyl group, at 1 position OH group. 1 phenyl, 2 propanol. In 1 phenyl, 2 propanol, pH at first position, then OH at the middle one. If we go for the reactivity of this alcohol, the thing is here, when we are considering the reactivity, first thing comes in mind how HBr will react with the alcohol. When HBr is reacting, actually it will form H plus and bromide minus. As H plus has formed, so OH will goes out in the form of water. As OH is going out in the form of water, positive charge, we will get positive charge in case of in the middle for compound number 3, 1 phenyl, 2 propanol. For compound number 2, we will get the positive charge in the corner, and in compound number 1, we will get the positive charge in the corner, but here phenyl group also attached. If we go for the SN2 reaction, we will consider the carbocation in case of SN1 reaction. But if we go for SN2 reaction, then we have to consider the backside attack. But as the carbocation formation is more favorable here because of carbocation stability, so we are considering the SN1 pathway. Now going for the SN1 pathway, first of all, for the first compound, the stability of the carbocation will be highest because of Plassard effect of phenyl group as well as Plassard effect of ethyl group. So the highest acidity will be for 1. Then we have 3. Why 3? Because if we go for 3 here, methyl group is showing Plassard effect, and here also hyperconjugative hydrogen, if we consider, then hyperconjugative hydrogen will be higher in case of compound 3 compared to compound 2, and in the last case in compared 2, the stability is only by this ethyl group. That's why acidity, that reactivity order will be first 2, then 3, then 1 in the increasing order. Means from 2 to 3 to 1, reactivity increases. If you want to calculate the hyperconjugative hydrogen, the rule is like, here is the sp2 hybridized carbon. Beside that one is sp3 hybridized, 3 hyperconjugative hydrogen, 2 hyperconjugative hydrogen. Here only 2 hyperconjugative hydrogen present, and here also only 2 hyperconjugative hydrogen present. So according to the stability, when we are considering the Placer effect, that one will be the highest stable. Then we are considering the Placer effect, and in between 3 and 2, 3 having 5 hyperconjugative hydrogen, whether 2 having only 2 hyperconjugative hydrogen. So here the reactivity order will be first 2, then 3, then 1 in the increasing order. Next, moving towards the question number 4. In question number 4, the question is the process of converting alkyl halide into alcohols involves. When we have alkyl halide having the general formula R attached with a halogen into alcohol, that means we are having one nucleophile hydroxide, and it will attack here, then it will come out in the SN2 method, or otherwise the carbocation will form, then hydroxide will attack in the SN1 method. Whatever the SN1 and SN2, they are part of substitution reaction. So here the option will be, the correct answer will be substitution reaction. In our next question we have CH3Br potassium cyanide giving H2O plus and lithium aluminum hydride. Maybe there are a few questions are involved where I've taken from acid part also, but you can continue this in alcohol part also because of conversion method. As we have methyl bromide, then potassium cyanide. In case of potassium cyanide, we have two type of possibilities. Whether it will attack through nitrogen side or carbon side. If we are considering silver cyanide, in case of silver cyanide, because of its covalent nature, here nitrogen will attack. In case of potassium cyanide, because of its ionic nature, it will form potassium plus cyanide minus. That's why it will attack through the carbon side. As CH3Br reacting with potassium cyanide in alcoholic medium, it will be converted into methyl cyanide, CH3CN. After hydrolyzing it, we will get CH3CO2H, and from CH3CO2H, if I add lithium aluminum hydride, this one is reducing agent, a source of hydride, and it will attack to the acid part and it will form CH3CH2OH, and the answer will be option number D, ethyl alcohol. For this, we have to see the order of acidity. To see the order of acidity, more the electron withdrawing group present in the ring, more will be the acidity. Here in this question we have phenol, we have parahydroxytoluene, metanitrophenol and paranitrophenol. For comparing the acidity, we need to see the electron withdrawing group. More the electron withdrawing group present, more will be the acidity. More the electron donating group, less will be the acidity. And for detailed explanation, you need to see my acidity basicity video. Now if we go for the electron withdrawing group, in case of nitro group is electron withdrawing. When nitro group is at para position, it will show its minus R effect. When nitro group will be at the meta position, it will show its minus I effect. And when we have methyl group in the para position, it will show its plus I effect. Or if we consider as methyl group plus I effect is very negligible as para position, still a donating group is present with phenol. Now in case of paranitrophenol, the acidity will be the highest. So acidity will be highest in case of 4. Then in case of metanitrophenol, means then 3 will come, and then the phenol compound, and because of presence of electron donating group, the least acidity will be in case of compound number 2. Here the correct order of acidity will be 4, then 3, then 1, then 2. So the correct option will be option number D. The reaction of the compound here given CH3CH double bond CH phenol group OH HBr else. When we are adding HBr, hydrogen will be added, bromide will be added. Where hydrogen will be added? Hydrogen will be added like the way the mechanism is like the bond will break, it will take the hydrogen and the positive charge will come on one of the carbon atom. There the bromide minus ion will attack, and depending upon the stability of carbocation, bromide will attack at that place. Here two possibilities are there of addition of H plus first. If H plus added in the first carbon, means in this carbon, then the carbocation comes here and the carbocation is stabilized by plus R effect of phenol group as well as the plus I effect of ethyl group. But if the second option happen, then only the carbocation stabilized with the plus I effect of methyl group and a little plus I effect of that side. That's why the correct option will be the bromide will attack here, and the correct option will be that one, the B option, CH3, CH2, CH, Beer, pH, OH. Going towards the next question, we have which of the following have positive iodoform test? This one is quite direct question because in case of iodoform reaction, we have to find out the group where a keto group is present with its alpha hydrogen. Then that can be iodoform positive compound, or a compound having OH and beside that CHOH, beside that a CH3 group present, that can be also a iodoform positive. If we go for all the option, if we see, then the first option does not contain any one of that group, so that one got cancelled. But the second option contain this type of group, the third option also contain, and the fourth option also contain. So 2, 3 and 4, all that 3 compound will be iodoform positive compound. In our next question, we have reaction of Grignard reagent. When Grignard reagent is reacting, basically that alkyl group having partial negative charge and that MgX part having the positive charge. So that R will attack to one of the CH carbon CH2, and that bond will break and will form CH2, CH2R, and O minus will get attached with another MgX positive, and after hydrolysis this O negative MgX part will become OH, and here the option will become RCH2CH2OH. Let's find the option RCH2CH2OH. Option D will be the correct option. In our next question, we have ethanol on reacting with PCl5. If we have first C2H5OH, it has reacted with PCl5, which is the source of chlorine. So it will be converted into C2H5Cl plus POCl3 and HCl as side product. Then if we add silver nitrate, which is a source of nitrate, silver plus and nitrate ion, and silver plus will withdraw the chlorine in the form of silver chloride as a side product, and here nitrate will form C2H5NO2. So the correct option A, the product A will be C2H5Cl and the product B will be C2H5NO2. So the correct option will be option A. I hope this video remains helpful for you. If this video is helpful, please give a like and don't forget to share with your friends. And if you have not subscribed to my channel yet, subscribe to my channel. More this type of video will come, and complete revision videos link you will get in the description box, and also the specimen paper solved given. So if this video is helpful to you, so thank you for watching.